Okay, today we're going to be using the distance formula and the Pythagorean theorem to find the distance between 2 points on the coordinate plane. Now before we begin, we want to find out what the distance formula is. And what essentially the distance formula is we have 2 points and we want to find out the distance in between those 2 points. So we are going to have 2 ordered pairs, first ordered pair, second ordered pair. And we want to find the difference of the x coordinates, and we want to find also the difference of the y coordinates. Once we do that, we're going to square those differences and then add them together and then take the square root of them. Okay? So for distance, our formula is the square root of x sub 2 minus x sub 1 to the second power plus y sub 2 minus y sub 1 to the second power. Now, when we are given 2 points, using the distance formula is the most ideal way. However, when we are on the coordinate plane, then we have 2 options. We can either use the distance formula itself, or we can create a right triangle by making a base and a height, and then we can apply the Pythagorean theorem that we learned in our previous video. And what we do is we're going to end up originally taking the square root of both sides so that we can get that diagonal by itself. And ultimately, it's going to be the square root of a squared plus b squared. So we're going to have this, square it, add them together, and we're going to take the square root. So another way to remember the distance formula via the Pythagorean theorem is by taking the base, squaring it, taking the height of that right triangle, squaring it, adding them together, and take the square root. Okay, so let's get started. So we want to find the distance between each pair of points, and we want to round our answer to the nearest tenth if necessary. So I'm going to move this up. All right. Now, one very important thing when you're dealing with distance formula is to label your points. So whatever you have, always label. So I'm going to write x, y, x, y. Now if you notice, I didn't write the sub 1s and the sub 2s in here. And the reason is that to avoid confusion, I like just writing in my x coordinates and my y coordinates in the order I see them. And we're still going to get the same results. Also, I like to write my distance formula skeleton so that I don't make any mistakes when I'm plugging numbers in. Okay? So remember, the first ones have to be for x. So these 2 guys have to be x. And these 2 guys have to be y. Okay? So when I look at my 2 ordered pairs, the 2 numbers for x are 1 and -5. So I'm going to write them down the way I see them. If you really want to follow the formula, by all means, I'm not going to stop you, but just make sure that you're consistent with your technique. Now for y, I see 8 and -4, so I'm going to write an 8 and a -4. Now notice that I had a subtraction sign to begin with in my formula, and then in addition to that, I wrote what type of number I had for my second x. So in this case, I had a -5, and here I had a -4. Now anytime you see a double negative, we automatically know that this turns into positive. Minus minus is plus. So I like to just draw a really big addition sign there, only when I see a double negative. Okay? You do not do this all the time. Okay? All right? So now our square root is going to start getting smaller and smaller and smaller. So 1 plus 5 is 6. So 6 to the second power plus 8 plus 4 is 12. 12 to the second power. Now remember, you can still use your calculator to figure out how to square numbers, or you can multiply this number by itself. So for me, my square root is getting smaller. 6 to the second power is 36, and 12 to the second power is 144. Now I'm going to add those together, 36 plus 144, and it looks like I'm going to get the square root of 180. When you get to this point, now grab your calculator if you haven't done so, and we're going to take the square root of 180. So I'm going to hit second x squared because that gives me my radical. And now I'm going to type in 180. Now remember, we're trying to round to the nearest tenth. So I'm looking at the 4. That's what I want. I look to its neighbor. This guy is just a 1. That means we stay the same. So we're at 13.4. Okay. So the distance between those 2 points is 13.4. Okay. And we call that units. All right. Let's try another one. Okay, we have 2, 5, and 3, -7. I suggest you write those down and then pause the video so that you can do it on your own. And then we can check back together in a bit. Okay, hopefully you labeled your ordered pairs, x, y, x, y, and you drew your distance formula skeleton. So I'm drawing it out. Remember, I always have subtraction in the parentheses. And now I'm going to write down my numbers. So 2 and 3 for x, 2, 3, and then 5 and -7 for y. Because I only have one negative here, that means I am subtracting. So 2 take away 3 is -1 to the second power. And here I do have a double negative. So that's where I can make that an addition sign. So 5 plus 7 is 12 to the second power. Okay. In your calculator, if you type in -1 to the second power, the -1 needs to be in parentheses, otherwise you're going to get a negative answer. And remember, this is a negative number times itself. So negative times negative is positive. So for this particular one, -1 times -1 for me is 1. And 12 times 12 is 144. Add 1 to that, and I'm going to get the square root of 145. Now with my calculator, one more time, I'm going to take the square root, so hit second x squared, which is the radical sign, 145, and I got 12.04. I look at the 0, look at the neighbor. This guy doesn't tell me to bump, so it's just a 12.0, or I can just say 12. So the distance is 12.0 units. Okay, not too bad, right? All right, so let's take a look at what happens when we do have the coordinate plane with us. Okay, so in this particular example, we already have a picture. And in this picture, we have the 2 points and we have a diagonal, okay? Now we have one of two options. We can either A, use the distance formula, or B, we use the Pythagorean theorem. So I'm going to show you both ways. And then in the next examples, I want you to decide which method would be best for you, okay? So method 1 is going to be using distance formula, okay? So on the top of my paper, I'm going to write for this side, distance formula. So, in order to use distance formula, you need to write the ordered pairs down. So you need to know the location of this guy, and you need to know the location of this one. Remember, we always start at the origin, and we decide left, right, up, down. Okay, so from here to get to here, I went left 1 and down 2. So I have left 1, down 2. So -1, -2. For this one, from the origin, I went 2 to the right and 5 down. So 2 to the right and 5 down is to -5. Now from here, all I have to do is use my distance formula the way that I've been using it. Okay, so label your ordered pairs. You got x, y, x, y. Write down your distance formula. So I got d is equal to, we got a big square root, subtraction in the middle. And now we're going to plug in our numbers. So for x, it's -1 and 2. -1, 2. For the y's, it's going to be -2 and -5. So -2 and -5. Okay. So from here, there is no double negative, which means I get to just subtract the way I have it here, I have it here. So negative 1 take away 2 is going to give us a negative 3 to the second power. Let me draw my square root. And here I have a double negative, which means I'm going to make this an addition sign. Okay? So that's negative 2 plus 5, and that's going to give me a positive 3 to the second power. Okay? Now I just simplify. Negative 3 times itself is going to be a positive 9, and a 3 times itself is going to be a 9. Add those together, and I'm going to get the square root of 18. Okay? So I'm going to stop here. I know I have to keep on going to find how long that segment is, but I want to now tackle using the Pythagorean Theorem modification, okay? So what if I try using Pythagorean Theorem? Well, what do I mean by that? I mean, let's draw a right triangle on this grid to help us find a base and help us find a height, okay? So if you look at our triangle, you can very easily see where we can make a base and a height. So I just find the vertical and horizontal lines that would make a triangle. So here's this line going down, and here's this line going to the right. And I have a right triangle, okay? So all you have to do is count how many boxes, how long that segment is. With horizontal and vertical lines, we can very easily count. We don't have to use the distance formula, okay? So when we count that, it looks like I am 3 boxes long, or 3 units long on my base. And then as far as how tall this triangle is, it is also 3 units tall. So I'm going to use my Pythagorean theorem. I'm going to use the modified version, which was c is equal to the square root of the base squared plus the height squared. Okay? So from here, the base for us is the bottom piece. So this is going to be 3 squared plus the height, how tall it is, and that's also 3 squared. Okay? And 3 times itself is 9. 3 times itself is 9. And to take the square root of that, we're going to now add 9, and give us 18. And if you notice, these two are the same answer, okay? That's a good thing, because it's showing you that either technique will work when looking for the length of a diagonal on the coordinate plane. It's just up to you which one's easier for you. So, because they're both the square root of 18, let's find the square root of 18 on our calculator. And that's giving us a 4.24 blah, blah, blah. So we round. Remember, we want the 2. We look at its neighbor. That's a 4. That means we're stuck with that 2. So the distance between those 2 points is 4.2 units. Okay? Not bad, right? Okay. Go on ahead and you try this last one on your own. Pause the video. You decide which method you want to use, whether it's distance formula or Pythagorean theorem. And then we'll come back and I will show you both techniques. Okay? So for distance formula, I have to first write the ordered pairs. So from the origin, how do I get here? And it looks like I went 1, 2, 3 down. I'm sorry, 3 to the right and 1 down. So I'm going to say 3 to the left, 3 to the left and 1 down. And from here I went 1 to the right and 2 up. So 1 to the right and 2 up. Okay? Label your ordered pairs. So this is xy, xy. And draw your skeleton formula so that you know what you're going to plug in where. So this is always squared, subtraction signs inside the parentheses, and addition sign in the middle. And we want our x's here and our y's here. So my x's are -3 and 1. And my y's are -1 and 2. No double negatives on the inside. Therefore, I don't change any signs. So we're going to now simplify. -3 take away 1 is -4 to the second power. And -1 take away 2 is -3 to the second power. Now again, with your calculator, you need to put parentheses around these negative numbers in order for you to get a positive answer. If you don't, you're going to end up getting negative results, and that's wrong. Negative 4 to the second power is 16, and negative 3 to the second power is 9, and 16 plus 9 is 25, and then we have to find the square root of 25. Okay, this is using distance formula. Now I'm going to show you with Pythagorean Theorem. Okay, remember Pythagorean Theorem means we need to draw a right triangle. So only horizontal vertical lines. So I need to draw a line going down, a line going to the right, and it looks like I have my beautiful right triangle there. Now all I have to do is count how many units long each of those is. So for my base, it looks like I took up 1, 2, 3, 4 boxes. And for my height, I took up 1, 2, 3 boxes. You see that? Okay. So for Pythagorean Theorem, we're going to use C is equal to the square root of base times height. So the base to the second power plus the height to the second power. Okay. So the base for us was 4 units long. So we're going to say 4 squared. Plus the height of this triangle is 3 units long. So 3 squared. 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, and now with your calculator, you're going to take the square root of 25, so second x squared, type in 25, and you should get a 5. Okay, so either one of those is going to be 5 units. Okay, well, I hope you learned quite a bit about how to use a distance formula and how you can use a modification of Pythagorean theorem to find the length of a diagonal on the coordinate plane. Until next time.